Alright, this is the fifth and final part of my summative calculus series. So this is not super in-depth, but today, or right now, we're going to talk about integrals and what they actually mean instead of just, arbitrarily doing it. What is it we're looking for? Now, generally, integrals will actually be notated because this is how they're used. They'll be notated by let's see if I have alpha beta on here. Yeah, it looks like I do. Alright, so we'll have alpha, beta, f of x, dx. Now what does this mean? Alright, now this means that this is going to be the interval on which we're looking for the integral. Now, this is the fundamental theorem of calculus. Alright, and what does this mean? Well, actually, no. This is the fundamental fundamental theorem of calculus. Right here. It's going to be that this is equal to, if you remember, this is a antiderivative notation. It's going to be minus the antiderivative of a. Not the antiderivative times a, the antiderivative of a. Alright, so this is going to be, this right here is equivalent to the antiderivative at b minus the antiderivative at a. Now, what are we talking about? What are we talking about? Say we have this function here. All right, we have this curve. All right, and this is our alpha, and this is our beta. All right, this area is what we're finding. We're finding area underneath this curve, and that is what this is denoting. This is the area under the curve, and this is going to be our formula. All right, so when we use that formula, all right, we're going to have the antiderivative at b minus the antiderivative at a. And what we're going to be finding is this. That's what we're finding here. And this is going to be our area. This is going to be our area. All right. So, how are we going to do this? All right. So, here's a basic example. So, we're going to have the integral on, I'm going to go from pi to 2 pi of, it's going to be of cosine of x dx. Alright, so what we're going to do is we're going to say this is going to be sine, as that is the antiderivative of 2 pi minus sine of pi. So this is really not that hard once you have learned your integrals. And so this is going to be sine of 2 pi is going to be 0, and sine of pi is going to be 0, so this area is going to be 0. Now the reason it's 0 is because we're going to have sections of this function, right? What that's saying is we're going to have something like this. Right? And this is going to be negative area. This is going to be negative area, and this is going to be positive area. Right? And these are going to be the same value, so they're going to add and subtract out. But let's do a little bit of a different example now that you know what we're talking about. So we're going to do the integral from 5 to, let's go, 17 of x. Alright? Dx. So what we're going to do here is this is going to be equal to, so this is, what is the integral of x? So we're going to use the power rule. X to the n plus 1 over n plus 1 is going to be x squared over 2. Alright, so we're going to have, 17 squared over 2 minus, and we're going to have 5 squared over 2. right? And this is going to be equal to 289 over 2, which is 144.5, minus 12.5, because that's 25 over 2. That's going to be equal to 132. 132 is our area. Now, why does this make sense? Why does this make sense? So, the reason this makes sense is if we take a look at this graphically, we know y equals x is going to be a line. We're going to say it's going to be this line. All right? So we're going to have this point, we're going to say this is at 5. This is at 5. All right, and then up here is going to be at 17. All right, up here is going to be at 17. 17. All right, now we have this triangle. All right, now the base, how do we know the base? The base is going to be x2 minus x1, or 17 minus 5, which is going to be 12. And the height is going to be the difference in the two values, which is, you guessed it, going to be 12. All right, or is it? All right, yes it is. So, but you also have to keep in mind we're going to have this area down here too. So we're going to have this triangle plus, have that triangle, plus this area down here. All right, so let's look at this from a geometric standpoint. So we're going to do 1/2 base times height, 1/2 base times height. All right, and that's going to get us 6 times 12, which is 72. Now we're going to have this, which is going to be 12 by 5, because we know this point's going to be 5 high, right? Which is going to be 60. 72 plus 60 is 132, which, what a surprise, is the value that we got here from this integral. So now you understand what this integral means, and this is really the baseline for calculus here. This is probably everything you'll need to know to do really well in your AP Calc class in high school or in college, to have a baseline, and you've pretty much seen it, and the class is just going to go more in depth. So thank you for checking it out. Be sure to try the practice problems, and yeah, thanks for watching.